Okay, here's your next lesson on prime factorization. Let's go ahead and go through some here. Find the prime factorization of 27. Let's first talk about what prime factorization is all about. Prime factorization is basically breaking down a number into factors, but in this case, only prime factors. Before, we were breaking down numbers into factors. 2 and 4 and 6, those were okay numbers to get. Now what we're doing is we're going to break it down into just numbers that are prime. So 27, for instance, if I were to break this down using prime factorization, I'm going to use something called a factor tree. I'm going to still use that same concept of factor pairs, and I'm going to try to avoid using 1. So 3 and 9 makes 27. If you run into a prime number, you circle it. It cannot factor anymore. The only thing that can make 3 is 1 and 3. Well, I could do that forever then. 1 and 3. 1 and 3. That goes on and on and on. So it would be a lot of wasted time if you use 3. Now what I'm going to do next is I'm going to branch off 9. 9 is composite. It can keep going. And I'm going to think of a multiplication problem that makes 9. And there really is just one. And that would be 3 times 3. And those are both prime. And there is your answer. 27 is equal to 3 times 3 times 3. Or 3 to the third power. Either answer is fine. This is considered expanded form. This is considered exponential form. Both answers are acceptable. Okay, let's look at 12 and let's break that down into just prime factors. 12, if I were to think of a multiplication problem, is 2 times 6. There's others, and if you did use another, like 3 and 4, you wouldn't get it wrong. So I'm going to circle 2. Why am I circling 2? Because it's a prime number. Prime numbers cannot be factored any longer. Then I'm going to factor 6, and 6 is composed of 2 and 3. And I'm going to circle those numbers because they are prime. So 12 equals 2 times 2 times 3. Those are all prime numbers, and they are factors, and that's it. How can we write that using exponents? We can write 2 squared times 3. Either answer is great. Let's look at 48 here. Now, 48 is kind of an interesting example to do because it has a lot of factors. So let's go ahead and start out 48. Now, there's a lot of ways you can start out 48. Let's just do one of them. 2 and 24. That's a way. I'm going to go a little bit faster here and circle prime numbers and branch off composite numbers. 2 is prime. I circle it. That can go no longer. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. And everything's done. So what did we get? We got 2 to what power? 1, 2, 3, 4. There are 4 2s, so I'm going to write to the 4th power times 3. There's your answer. 2 to the 4th power times 3. Now let me show you another way to do this. Before we started with 2 and 24, let's think of another multiplication problem. Let's say we start with 4 and 12. 4 and 12 can be branched off into 2 times 2, and 12 can be 2 times 6. I circled all the prime numbers. I'm going to branch off composite numbers. 6 is 2 and 3, and I circled the 2 and the 3. And look what I get. I get the same thing. I have 4 2s, 1, 2, 3, 4, and are all those prime? Yep. And I have 1, 3. Same result. I started it out different though, 4 times 12. So it doesn't matter how you started. What's another way we can start it? Maybe most of you were thinking 6 and 8. That's a typical multiplication problem that makes 48. 6 is 2 times 3. 48 is 2 times 4. 4 is 2 times 2. And lo and behold, we have 4 2s. 1, 2, 3, 4. 2 to the 4th power times 1, 3. So I hope you get the idea here. No matter how you do prime factorization, no matter how you start it, you always end up with the same result. Granted, you do your arithmetic right. If you think that 48 is 6 times 9, well, yeah, you're going to miss it, even though you might branch everything else right. You started it out wrong. So if your arithmetic's off, then your answer, yes, of course, that will be off. Okay, let's look at a big number now. Don't be too intimidated by big numbers. 200, yes, it's larger, but it doesn't have a ton of factors. Let's look at this. 200 is made up of 2 times 100. I'm going to circle the prime number. 100 is made up of 2 times 50. And then I'm going to circle 2. 50 is 2 times 25. There we go. And now I can no longer use 2. So let's use another number that divides into 25. And 5 and 5. There you go. So what's our answer? 2 to the third power times 5 squared. And there you have it. Let's look at this another way. Let's break down 200 and think of it differently. Let's think of it as 20 and 10. 20 is 2 and 10. I'll circle 2. 10 is 2 and 5. I'll circle both of those. 10 is 2 and 5 here. Same thing. And same end result. How many 2's do we have? 1, 2, 3. How many 5's do we have? 2. 2 cubed times 5 squared. That is what 200 is. Let's look at 153. You know, looking at this, you might be like, I can't think of anything that makes 153. But let's go through our factors and just see if it works. Does 2 work? Well, it's not even, so we can't say 2 works. Let's try 3 now. Does 3 work? Well, the rule for 3 is if you add up the digits. 1 plus 5 plus 3. And that adds up to 9. Does 9 divide by 3? Well, of course it does. So this number is divisible by 3. So now that we know that 3 is divisible into 153, let's figure it out. 3 divides into 153 5 times. Subtract. Bring down. And you get a 1 here. So we get 3 and 51. And then 3 is prime. Is 51 prime? I don't think so. 5 plus 1 is 6. So let's try 3 again. 3 is prime. 3 times what? 3 times 17. And both of those are prime. And there you have it. 3 squared times 17. Okay, here's 1,000. This is a huge number, but don't be thrown off by how big it is. 1,000 is just what? 10 times 100. And what's 10? 2 times 5. Okay, that side is resolved. Let's do 100. 100 is, let's do 4 times 25 this time. 4 times 25. Any of those numbers prime? No. 4 is 2 times 2. 25, 5 times 5. And there you have it. There's your answer. How many 2's do we have? We have 1, 2, 3. So this is 2 cubed times 5 cubed. 1, 2, 3, 5s. No matter how you do that, you should get 3 2's and 3 5s. Okay, that does it for your lesson on prime factorization. If you did not understand something, please go back, review what I talked about, and bring any questions to class the next time you see me. Have a great night.